Good morning, folks. My name is Bob Duffy, and we are going to be presenting a 10-minute talk on Star Schema automation for EDWs, specifically a SQL dedicated pool. Now, let's just go on to see. What we're going to do is we're going to try and over the next kind of 10 minutes build an entire Star Schema extract, transform, and load. Okay, so we're going to be taking AdventureWorks files, but not the AdventureWorks that you're probably used to, like the retail cells. There's actually an ERP embedded in AdventureWorks, so it's got a general ledger and all of the accounting dimensions, and we're going to extract them into a staging area and then do the transform and load to create the sort of Star Schema that you could use to import into Power BI, right? That I've shown on the kind of diagram here. I'm going to spend a little bit of time in the extract, but most of the time I want to focus on the transform and load. How do I build those dimensions and facts, assuming that I have the information staged, okay? Because most people are fairly okay with, how do I automate doing extracts. So here in SQL Management Studio, and just refresh that, I've just got one staging table. So I've got no staging tables at all. All of these tables are framework, so metadata tables in the config schema, login and lineage in the audit schema, right? So this we would ship as kind of standard, and I do have this available on a Git repository as well, right? So I populate a data table that describes the extracts I want to do. So for every file I want to bring in, what subdirectory is it on the data lake? Am I going to infer the schema, or am I creating the schema manually? A lot of techniques will infer the schema for you now. And if it's a CSV, I'm going to need to know some things like where is the first row, has it got a header, text encoding, and so forth. Typically, the TSQL that's generated will look something like this, right? If we're going to use a copy into, a developer could type this command, or could type a much longer set of commands by using polybase, create external table, right? Or he could be using ADF to try and generate this, or he could be using the ADF bulk insert command, especially if he's using something like a SQLDB as opposed to a pool, which doesn't support copy into or polybase. Now, obviously, if you've got thousands of files, getting lots of developers to write this repetitive stuff isn't a great idea, right? Because refactoring a waste of their time. So what we do is write a stored procedure to effectively automate the generating of the copy command. So reader extract will take all the settings and determine the code to be written dynamically by using dynamic TSQL. So when I run this, it will create the table if it needs to, and then do a copy into. Okay. Now that we've automated one file, let's use a controller worker pipeline here. So here's a controller pipeline. It's going to call a worker to execute the work, and there'll be a library of what's supported. Now in this kind of demo version, we only support CSV files, Excel files, and Synapse-based extracts like copy into a polybase. But in a commercial version, we obviously have a lot more ones available. So let's just hit debug, and I'm just going to run it in debug mode, and you'll see it will start hopefully on the output. Here you go. That started to run, right? So it's going to log the, it's going to do the login, and then it's going to go to the for loop, and then for every, and then the worker is going to decide which appropriate pipeline to use based on the type of file, and it's going to import it. Okay. So let's just wait for this to finish, and that's finished, right? So when I flip over to my tables, I've now got all of my information staging, whether it's come from Excel, JSON, CSV, or so forth. Now, let's look at the building of the bus matrix. So the first thing is, if we look at the bus matrix, we're going to build a metadata table that stores all our dimensions and our facts in our target schema, how they relate to each other, so effectively a soft code in the joins, and where their sources come from. So if we look at this mapping table, every source is going to have a staging table and some rules, how it's joined, transformed, casted, converted, and all the stuff that you do in data engineering, right? So that soft coding looks like this. EDW tables is going to store a list of all the tables in my EDW, right? So all my dimensions and facts. I run this, and I've now got the starting metadata table, and I've added some stuff here that describes for a dimension the business keys, primary keys, and various bits that are going to help me build the metadata. I might also describe the load process. Am I doing updates? Am I doing inserts? Am I doing deletes? Do I want it to automatically dedupe rows? Do I want to force using a CTAS? Do I want to force using a merge? Do I want to force a drop and recreate? These are all different design patterns that you can use to load, right? So what we do is similar to the extracts. We have a very sparse metadata table where most of the columns are null, but we can flick something on if we want to change the behavior of the load. Now, in order to do the transform, we then create a library of views for the basic transform. Okay, so here we can see this is a very basic view. It's doing casting, conversion, renaming. It's actually doing a self join because it's a parent child, so it's bringing back the kind of business key of the child, but this isn't a very complex view. So when I create that, I'll have some sort of integration schema that'll have all this kind of library of objects, and we can then write a stored procedure that uses the metadata to generate the dimension table automatically. So we no longer create star schemas by issuing create tables and physically creating tables. They create themselves. Now let's just run this one. Okay, so we're going to try and create our first dimension, the account. So it's running away. And that's finished. Noted that that's automatically created the table. It's done an insert into, and it's automatically created the index. Okay, that's all handled by reading the metadata columns and using dynamic SQL to do that. If I run it a second time, if it's going to have updates, it can generate an insert and an update as we see before. Okay, and if I had ticked the flag on the metadata to do a delete, it would have automatically deleted it. Now, fact tables are a little bit more complex because if we come back to our bus matrix, our fact table may have to be related to each of the dimension tables, and unless you're using natural keys, you might have a surrogate key. So the TSQL that's generated is going to have to be more complicated because it's got to join to the dimension table to bring back the kind of surrogate key, and it might have to do early arriving facts to insert inferred members and stuff like that, right? So let's look at how we would model that relationship. So what we do is we create a many-to-many table, EDW table joins, right? That models join. So if table 7 is my fact table, that's going to be related to dimension 1, 3, 4, 5, and 6. So date, account, chart of accounts, department, so forth. And then when I do that, I can then load that. Now I might just do this in SQL Management Studio because the Azure Data Studio doesn't quite render the TSQL nicely, so you can see what it's formatted like. So let's do this. Let's give this a shot. So I'm going to open a new window, paste that, and let's run this and see what TSQL it generates. So that's running away. So when this runs, I can see the results, and I've now got my fact table with my surrogate keys, my measures, a lineage key, and anything else that I want. I think it's just a test that we had. And I can see that it's generated a CTAS statement, select from, and that's in a join to each of the dimensions. Now I can modify the metadata to change that to a left join if there were some unknown members and stuff like that. If I run this a second time, obviously the table's already created. So depending on whether it's configured to auto drop is whether it will do like a delta base, so it might insert but only where the rows not exist. Okay, so that's an example of fact table loading. When I come back to Management Studio, I can refresh, and I should now have my entire star schema. I've got all my dimensions, I've got my fact. Okay, it's only a single Star Schema, and all of the data is loaded and transformed and ready to put Power BI or do my analytics on top of it. So here's an example Power BI report that I've created on top of that. I've got a profit and loss, a balance sheet, and a cash flow, and it's all coming from the SqlPool. Okay, that's a very quick foray into attempting to automate building an entire Star Schema in 10 minutes. Thank you very much.